Hello, welcome again. We are solving some questions of machines and the topic is friction and screw, bearing and clutches. Question number 4 and 5 carries a common statement. The statement is the following data relate to a screw jack, pitch of the threaded screw 8 mm, diameter of the threaded screw 40 mm, coefficient of friction between screw and nut zero point 0.1, load 20 kN, assuming that the load rotates with the screw. Question number 4. The ratio of torque required to raise and lower the load. Option A 4.56, option B 3.56, option C 2.18, and option D 5.21. Question number 5. The efficiency of the machine when the raising of the load is considered. Option A 53.1%, option B 38.6%, option C 45.2%, and option D 52.1%. So here tangent alpha or helix angle is given by P by pi d. So P is your pitch and D is your diameter of screw. So pitch is given as 8 mm and diameter of screw or mean diameter is given as 40 mm. So from this we have alpha as 3.64 degree and coefficient of friction is given between the screw and nut is given as 0.1. So that is so from this we can calculate friction angle, that is 5.71 because mu is equal to tangent pi. Okay, now to raise the load we have used that formula, that is F is equal to W. To raise the load or weight, the load required is F is equal to W tangent alpha plus pi, and the torque required is F into R, or T is equal to W tangent alpha plus pi into R. Okay. W is your 20,000 and alpha is 3.64 and pi is your 5.7 and R is your radius is your 0.02. Radius of the, because diameter is given as 40 mm, okay, so radius is in meter is 0.02 meter. So that will be torque required to raise the load is 65.86 millimeter. So that formula we have used in previous question, so no need to drive it. Okay, and to lower the load, just this pi will come here and alpha will come here. To lower the load, the torque required is W tangent pi minus alpha into R. Okay. So and there will be minus sign between them to lower the load. So that torque required is your, putting the values, we have all the values, that is 65, that is alpha is equal to 3.64, pi is equal to 5.71, W is equal to 20,000 and R is equal to 0.02. So that is 14, that comes out as 14.42. So the ratio of the torque required to raise the load and ratio of the torque required to lower the load is 65.86 divided by 14.46, that is 4.56. Okay. Now that, so answer to question number 4 is A. Okay. Now the efficiency of the machine when raising of the load is considered. So when raising of the load is considered, the force required is your W tangent alpha plus pi. Okay. So and when friction is not considered, then the load required is F W tangent alpha. Okay. So that so the force required will be minimum when friction is not considered. So that is your W tangent alpha, or we can say torque required will be minimum when friction is not considered. So that will be W tangent alpha into R. Okay, so that will be minimum, and the load, the torque or force required will be maximum when the friction is considered. So that is your W tangent alpha plus pi. So R will cancel out, W will cancel out. So the efficiency while moving up will be tangent alpha divided by tangent alpha plus pi. So the now putting the values, we can calculate the efficiency during moving up, that is 38.6%. Okay. So that is the efficiency that can be found out by this simple formula. If we neglect friction, then the force required will be minimum or torque required will be minimum. If we consider friction, then the torque required will be actual or maximum. So force required or torque required or minimum torque required divided by actual torque required is your efficiency. So that is 38.6%. 6%.